Alright, in this video we're going to be taking a look at this. This is a spectrum analyzer. It's a HP8595E spectrum analyzer, and it's a 9 kilohertz to 6.5 gigahertz bandwidth. This is the analyzer. If you have been watching my videos, back in some of the very first videos I did, I upgraded this spectrum analyzer to include the tracking generator option. Well, that was a few years ago, and since then I've noticed that I don't think this analyzer is working correctly anymore. And here is the issue. Well, there's actually two issues. One issue is this power switch, this line switch here is really it's really kind of it's really kind of sticky, and when you turn the unit on, you have to really fiddle with the switch to get it actually to pick up, and that's an easy fix. I've got a replacement switch. We'll put that in. But the bigger issue is I don't think it's working correctly on the high band. And here's what we're looking at right here. Just look at the screen. So right now we've just got the analyzer sitting here. It's got the cal out going into the RF input, and so we're looking at the harmonics. And the first harmonic here, 300 megahertz, is at minus 20 dB, which is where it should be. And then you get harmonics. There's a 600, 900, 1200, 1500, 1800, 2100. This is the 2400, 2700, 3 gigahertz, 3300, and the 3600, or the 3.6 gigahertz. These are all the harmonic spurs. But what happens here is so this is the 3.6 gigahertz spur. The next spur should be 3.9 gigahertz, and there should be one more at 4.2 gigahertz. The spurs should, from what I've seen on other analyzers, is the spurs should extend out to this graticule line here, this all the way out to here at least 4.2 gigahertz. And you can barely see there's a spur right there, and then there's nothing after that. Now, and what I've noticed, and if you watched my previous video where I fixed this HP86290B plugin, you might have wondered why didn't I use the spectrum analyzer to look at the tuned oscillator? Because the tuned oscillator, the aux output goes from 2 to 6.2 gigahertz, and that's an easy check to look at to verify operation on the spectrum analyzer. Well, the problem is because when I was working on that sweep generator, I found this problem out. And so what I'm going to do is I'm going to hook this up, and I'll show you exactly what I'm talking about, the problem I found, and we'll go from there. We'll put the unit through some self-checks, and we'll see if we can figure out what the problem is. I've been reading the service manual on this unit, and I think I've got some ideas as to what may be the problem, and hopefully it's something that's economically viable to repair, because the parts for these units are quite expensive. Alright, so here's our setup. Got the sweep generator plugged in, and I've just got it set up like this. I don't have, the really good microwave cables, so I'm just trying to use this short piece here to minimize the loss. Right now I've got it set in CW mode, and we've got a 2 gigahertz tone on, and we're set on the power meter for minus 10 dBm going into the spectrum analyzer. So there's a 7 dB loss here across the power splitter, so it's going to be about a minus 3 dB signal going in with the 7 dB loss. going into the analyzer. So right now we're sitting, here's our 2 gigahertz tone, and we'll just do a peak search on that. Let's see. And next peak, there we go. So, alright, so here we are, we're sitting at 2 gigahertz at minus 10.9 dBm on the analyzer. So what I'm going to do is I'm just going to do I'm not going to do an automatic sweep. I'm just going to manually adjust the generator, and we'll sweep it through the band, and I'll show you what the spectrum analyzer is doing. So I'm raising the frequency, and as you can see, it's sweeping across, and it's staying fairly power level staying fairly constant. Part of the dips here are due to the signal generator I'm using. It's not really in cal. It's not exceptionally flat on the output. So we're getting some drops in the peak here. But now we're gonna do, let's see, next right. All right, so now we're at 3.7 gigahertz, and we're showing a minus 16 dB, and the power meter is showing a minus 9 approximately tone. So here's where I started noticing the problem with the analyzer. So this analyzer has 2 bands. It's a band 0 and a band 1. The band 0 goes from basically the bottom 9 kilohertz to 2.9 gigahertz, and the band 1 starts at around 2.7 gigahertz and switches to the full 6.5 gigahertz. So as long as we're in the low band, everything seems to work fine, and I'm going to get it adjusted back to the low band. Alright, so there we're right in the cusp of the low band. And we're at 2.7 gigahertz, still showing what is that, minus 10.9 dB on the analyzer, and we're showing a minus 9.8 on the power meter. So we got a 1 dB discrepancy. But as we roll on through, we'll notice that our power level is going to start dropping off, and here it becomes very noticeable that we're at 4 gigahertz now. We've got a minus 25.7 dB, and our power meter is still showing minus 8.5.6 dB. And continuing on, I'm going to take it all the way. So now we're at 5 gigahertz. This should be about 5.2 gigahertz. Yeah, 5.2 gigahertz. We're at almost minus 50 dB there. And our power meter is still showing a minus 8.4 dB. And I'm going to take this all the way out to the top of this band. I'm on the 2 to 6.2 gigahertz band. And so now we're at the top of this band. And we can look at our peak here as dropped down all the way to minus 56 dB on our tone. And our power meter is still showing minus 8.1 dB. So that's a pretty big discrepancy there between the analyzer and what the power meter is showing. So what I suspect is that there is a problem somewhere in the signal path from the RF input to on the high band signal path that goes to the just goes into the input to the IF. I don't think there's a problem with the IF section just yet, and I will show you what I mean here with a minute. We'll get some drawings out and we'll look at the block diagram of the analyzer, because it seems the unit seems to work just fine on the low band. It just the problem seems to be isolated to the high band. So this is something I've recently discovered since working with this this sweep generator here. So I don't know how long this problem has been there. It may have been since as long as I've had the unit. But anyway, we'll get out the block diagram. We'll take a look. I'll tell you some things I'm thinking that we can check, and we'll go from there. All right, this is the block diagram for this particular analyzer. This is for the 8595E. This block diagram applies to several analyzers in this line. This one in particular is for the one I have. But anyway, we'll walk through the signal here. So here's our RF input connector. It goes through a 0 to 70 dB attenuator, and then it goes to a switched Yig-tuned filter. Now, from reading on the in the manual, the way I understand the Yig-tuned filter works is it basically tracks. It gets driven from the analog interface, and it tracks what the incoming signal should be based on the reading from the counterlock board, and it tunes this filter to be within a band. It's a bandpass filter, as you can see from the schematic symbol here. But it tunes the band to be within a range of what the incoming signal should be, so that it can sort of zero in, I guess, on that incoming signal. From there, the output goes to a dual band mixer, and on the high band, it's a down converter mixer. So what the mixer does is it mixes the incoming signal, the incoming RF, with the signal out from the Yig-tuned oscillator here, and the product that comes out of the mixer is, as I said, down converted to 321.4, and this says gigahertz, but that's a misprint. It should be 321.4 megahertz. All right, that down converted signal is then sent to the second converter here, which doesn't get converted at all. It's simply switched through this switch to a bandpass filter, 321.4 megahertz, and then that signal goes to the third converter, which then gets converted down to the final IF frequency of 21.4 megahertz. From there, it goes to, from there the signal goes to some bandpass filters, amplitude control module, goes through some more bandwidth filters, and through the log amplifier detector, and at that point the IF chain is complete, and this is a video signal out that gets processed by the processor and then displayed on the screen. And so our IF section, which includes, let's see, reading along in the manual here, starts at the A9 assembly, which is here. The IF section starts here, and it includes this portion here up to the output of the log amplifier, which is here. So that's our IF section. And our RF section is everything from the input connector up to the input to the third converter. So that's our RF section. And then the video section is the rest of the portion down here in the bottom of the schematic. The unit has a lot of really extensive, it's got some built-in test functions. The unit uses a lot of DACs, digital analog converter blocks, to basically, essentially what it does is it takes your cal output, which is here, and it uses this as a known reference, and it calibrates this whole chain all the way out to the video output, and it calibrates that whole chain to give you the best response on the display. So as long as your cal output signal is correct at 300 megahertz and minus 20 dBm, because that's your reference, the unit's going to calibrate itself to that known value. Now I'm pretty confident that the RF output or the cal output signal is good, but we'll check it. And but it uses all of the calibration data to adjust these DACs. Here's the reference level cal here, part of the cal amplitude. There's the DAC for it there, and there's other DACs in here that do things with the amplitude control. Has DACs associated with it. There's a lot of the DACs are on the A7 analog interface here. There's controls for frequency flatness. There's DACs to control the attenuator blocks for the to adjust the attenuator pads to make them have a sort of flat and even response. There's all sorts of things, but the first thing we'll do is we'll go ahead and I'm going to run the amplitude cal and the frequency cal on the unit. All right, so let's check the cal out signal. Now, the service manual is very extensive. It's almost 700 pages long. Of course, it covers all the analyzers in this HP 8590 series. But even with weeding out the other manuals, it's still very extensive. It doesn't give component level information, but component level information is available if we need it. Right now, I'm going to see if we can just use the service manual that we have, which is free download on the internet. So right now, I've got the cal out signal going into another spectrum analyzer. See if I can get this glare off the screen. Because the reason I'm using the spectrum analyzer is if you read the service manual, it talks about taking RF power level readings inside the unit, and this one in particular, it tells you specifically not to use wideband power sensors like the sensor I used earlier for the demonstration, the 8481A sensor, because a lot of the signals in this unit have harmonics. This one in particular is specifically set up to have a lot of harmonics, and those harmonics will throw off your power level reading. I forgot about that, and I took a reading with using the power sensor, and the power level was quite high. It was around minus 18.5 dB, where the schematic specifies for the cal out signal a power of minus 20 dB plus or minus 0.4 dB, so it has a fairly tight tolerance on the power level. So to avoid troubleshooting a problem that wasn't really there, luckily I remembered that you can't use a power sensor to take that reading, so I didn't. So we've got our reference spectrum analyzer set up, and this is the next best analyzer I have for the 6.5 gigahertz band. This one will go to 3 gigahertz, so it's going to get us part of the way there. If we have to do extensive troubleshooting, it's not going to get us all the way there. But here's our cal out signal. We're looking at right at 300 megahertz and minus 20.6 dB, minus 20.6, 20.7 dB. So that is well within our specified level for our cal out signal. Back on the analyzer now, we've got the reference, the cal out signal hooked back into the RF input. And so what we're going to do next is I'm going to go ahead and run the cal frequency and the cal amplitude routines, and we'll see what what kind of response we get. Now, I may not have mentioned earlier, but on power up, this unit doesn't give any. There's no error codes or failure codes given on the power up, so we don't have that. We don't have that information to go by. All right, so I'm gonna go ahead and run the tests, and then I'll show you we'll talk about the results when they get done. All right, let's run in the cal frequency routine now. The manual specifies when you run the cal frequency and the cal amplitude, that you should run the cal frequency routine first. And if you follow in the manual, it's written out that way where you run the cal frequency test first. There's measurements, adjustments that the cal frequency routine makes that will affect the cal amplitudes. That's why it specifies to run the cal frequency first. All right, and our cal frequency is done. It did not bring up any errors. We will go ahead and hit the cal store, because you have to store the values every time you run the routine. And so there we go, we got the cal stored message. All right, so now we're going to do cal amplitude. And I think this routine runs a little bit longer than the cal frequency. We'll look at the results when it's done. All right, and our cal amplitude is done. Again, didn't see any issues with the routine, so we will hit the cal store, and we'll save the calibration constants. All right, one more thing we'll do before we go on is we'll go ahead and run the cal YigTune filter. Because that is in the high band, and that could give us could be one of the sources of our problem. All right, and we completed the cal YTF, and these are the results of our cal YTF. So we hit store cal. All right, so after the cal YTF, basically reset the unit, hit the preset, the unit resets, and so now our basically looking at our cal out going into the RF. These are all of our harmonics. So now we're looking at 300, 600, 900, 1200 megahertz. We're going to go 15 or 1500, 1800. 2100, 2400, 2700, that's that 3 gigahertz tone there, 3300, 3600, 3900, 4200, and there's just a little bit of tone, just barely visible there at 4.5, that would be at 4.5 gigahertz. So it looks like we've had some improvement. We've run all the cal routines. We ran the cal YTF routine. So I'm going to go ahead and hook it to the back up to the sweep generator, and we'll see if our results have changed at all. All right, and we're back. We've got the same setup before. We're connected to the sweep generator. I'm sweeping the full band of 2 gigahertz to 6.2 gigahertz, and we've got our power meter set up again with the same setup. We're minus 10 dB down, and here's our sweeping the full band. So it looks like our problem has been resolved, because here's our tone, as we can see, and it's sweeping. And it's sweeping all the way across the full band. And we're not getting those losses in that drop off in power like we had before. So it would appear that simply running the cal YTF routine fixed the problem. I don't think the cal frequency or the cal amplitude really fixed it. I think it was probably running the cal YTF. I've still got to take the unit apart and change the power switch. I'm going to check the RAM battery and see if the battery's low, because this unit after when our basement flooded out. This unit spent a lot of time, a few months in storage, unplugged. So it's quite possible that the RAM battery is gone. I'm gonna check it and change the power switch. But anyway, this turned out to be a fairly uneventful repair. But I hope you it still helps somebody out and some informative information for this analyzer. If you have these sort of problems, maybe it simply running the calibration routines may fix your problem. That's all for this video, and I hope you enjoyed the video. And we'll I'll get on with some more repairs, and I hope you stay tuned for the next one. Thanks.